So here I want to discuss about the binomial distribution. Let x be a discrete random variable with parameters n and p. Then the probability mass function, in short form we can say PMF, of the bivariate x is given by. So this bivariate means the random variable which follows binomial distribution is given by probability x equal to r is nothing but NCR p to the power r q to the power n minus r. So where r is nothing but 0, 1, 2 and so on, so value of the random variables, and and P plus Q should be equal to 1. So under the binomial distribution, probability of success plus probability of failure is equal to 1. It is denoted by B of n semicolon P. So B stands for binomial, NP stands for parameters. Remember, in the case of discrete binomial distribution, N and P are two parameters. If we have P, we can able to calculate Q, or if we can have Q, you can calculate P. So N and P are two parameters. So if we define a probability mass function for a discrete random variable x in this way, then we say that x follows the binomial distribution, or x is a bivariate. Now let us first evaluate the MGF, moment generating function of the bivariate. So MGF of B n semicolon P. What will be the moment generating function of the binomial distribution? Now we know that this binomial distribution is related to a discrete random variable, and under discrete random variable, the formula of moment generating function is nothing but m of t summation r equal to 0 to n e to the power tr into ncr p to the power r q to the power n minus r. So here PR is equivalent to, this means summation r equal to 0 to n e to the power tr and PR. So here you see I can say this is equal to PR. This is equal to PR. So PR is the probability distribution, and I am putting PR equal to MCR P to the power Q to the power n minus R. And if I further simplify this, I can have this one in the form n equal to 0 to n, R equal to 0 to n, and here I will take NCR outside. So here t to the power r is there, here p to the power r is there. I will combine both of them, and I will say e into p to the power t whole to the power r, and then q to the power n minus r. So if I have p plus q to the power n, I can write here in r equal to 0 to n ncr p to the power r into q to the power n minus r. But here I am, in place of p, I am having p e to the power t. So we can write it as p e to the power t plus q whole to the power n. And this is nothing but my m of t, mgf. So mg of a binomial distribution is nothing but this one. Now once after getting mgf, we will try to find mean and variance. So mean of x. So we denote it as expectation of x. We denote it as expectation of x. Now expectation of x is nothing but m dash of t at t equal to 0. Now we will find derivative of m with respect to t. So n into p e to the power t plus q n minus 1 and derivative of the inside function. So that is p into e to the power t, and I will put t equal to 0. So if I put t equal to 0, what will happen? N into p e to the power 0 is 1, p plus q to the power n minus 1, and here e to the power 0 is 1, so it will be p. It will be p. And so finally p plus q is 1, so 1 to the power n minus 1 is 1, and I will get np. So expectation of a bivariate x is nothing but n into p, where n is the number of trials. Here you can say n is the total number of trials, r is the uh, value of the random variable. That means it will be the number of trials favorable to the particular event. Then we can have the expectation is nothing but n into p. Now I can calculate expectation of x square. Expectation of x square is nothing but m double derivative with respect to t, and I will put t equal to 0. So if we find the second derivative of this one, we will get this one as already one time derivative is this one. So here n into p outside, and p will be outside, and remaining thing will be derivative of e to the power t will be e to the power t. So we can write here e to the power t into e to the power p into e to the power t plus q n minus 1 plus e to the power t will be as it is derivative of this one u into v formula I am applying, and derivative of this one will be nothing but n minus 1 into p e to the power t plus q n minus 2 into p e to the power t, and then I will put t equal to 0. Then I will put t equal to 0. Then if I simplify it, what will get? Np will be there, and e to the power 0 means 1, p plus q to the power n, p plus q to the power n minus 1, and then here I will have e to the 0 n minus 1, n minus 1, and then it will be p plus q to the power n minus 2 into p into p. So what we will get here is so np into 1 plus n minus 1 into p, since p plus q equal to 1. And so what we will get here, this is equal to, if I multiply it, np plus np into np minus p, and so this is nothing but np plus n square p square minus np square. This is equal to expectation of x square. Now variance of x is nothing but expectation of x square minus expectation of x whole square, and that is equal to np plus n square p square minus np square minus n square p square. So plus n square p square minus n square p square getting cancelled. Np into 1 minus p. And so Np q. So this is the variance of a random bivariate x. So variance of x is equal to Np, where P is the probability of success, Q is the probability of failure, and N is the number of trials. Now here I will give you the central moment formulas. Central moments for the binomial distribution. Central moments for binomial distribution. So what are the central moment of binomial distribution is? So here we will write the kth central moment, the kth central moment denoted by mu k is given by is given by is given by mu k is equal to expectation of x minus expectation of x all to the power k. But you know expectation of x is for the random variable x, bivariate random variable x is np. So we can have this one as expectation of x minus np to the power k, to the power k. But this x can have the random variable value r. So we can write here, we can write the expectation of this one as summation r equal to 0 to n r minus np to the power k into ncr p to the power r into q to the power n minus r, because this is your expectation. This is the formula and this is the expectation. Now we find that here we will have mu 0 equal to 1. We can have mu 0 equal to 1 and mu 1 equal to 0. If we put those values, we can have this one. And so further what I will do, let me consider is equation 1. Now I will differentiate equation 1 with respect to p. Differentiate 1 with respect to t, with respect to p, with respect to p, and simplify. Simplify. We get what we get, d mu k divided by dp is equal to t mu k divided by dq equal to, we will get is pq into simplifying this one. So here we will have whatever thing we are having, that we will differentiate it with respect to, will differentiate with respect to here this one with respect to p. And if we simplify, what we will get is, just you leave this direct formula I will give you. If I differentiate and simplify, we will get mu k plus 1 is equal to pq into d mu k by dp plus nk mu k minus 1. So this is the general formula for calculating the kth moment of a random variable x where these two things are available, mu0 equal to 1 and mu1 equal to 1. Now if I put k equal to 1, k equal to 1 means what will happen? This will be mu2 and pq, and then this one will be mu1. Mu1 will be 0. Mu1 will be mu1 will be 0. So this will be 0 and mu0 will be k equal to 1 I am putting, so n into 1 and mu0 will be nothing but 1. So I will have n, and so which will give you npq. So this is your variance of x. This is your variance of x. Suppose I will take k equal to 2. K equal to 2. Then what will happen? Mu3. Mu3 will be nothing but d mu2 divided by dp plus 2 into n into mu1. But mu1 is already 0. Mu2 is this one. And so this will be nothing but d by dp. Mu1 is 0, so here I will have n into p. Q is also 1 minus p. So if I differentiate it and if I simplify it, what we will get? We will get it as like this: mu3 is equal to npq into q minus p. This will be the third moment of the random variable x. And similarly, we can have mu4 is nothing but pq into d mu3 by dp plus 3n mu2. And if you simplify it, that will give you npq into 1 plus 3pq into n minus 2. So like this we can find the central moment of a bivariate x.